A caustic soda mixer can have adequate capacity and still expose operators to corrosive liquid, moving agitation, uncontrolled overflow, and slow leaks. The real buying decision is whether the tank controls routine high-risk moments. Adding chemicals, checking a moving batch, opening the lid, managing excess liquid, and cleaning or servicing components after use. Sodium hydroxide presents skin, eye, inhalation, and emergency response concerns. In drilling fluid operations, those hazards are concentrated around sacks, hoses, pumps, tanks, and moving equipment, often under time pressure and in limited space. Manual or open tank mixing transfers much of the risk to operator discipline. Workers may stand close to an open liquid surface, inspect the process by sight, or clean residue after repeated minor releases. The first purchase gate should be controlled access during agitation. A protective lid must do more than reduce splash. It should fit securely, withstand routine use, and remain easy enough to operate that crews do not bypass it. Hinges, seals, latches, cleaning access, and visibility all affect whether the lid functions as a genuine control or becomes an inconvenience. An interlock or automatic shutoff provides stronger protection by preventing agitation with the lid open. The PRM CSMU 002, for example, uses a safety air shuttle valve so the agitator operates only when the protection lid is closed. Opening the lid shuts down the air supply and stops agitation. Buyers should demonstrate this function, confirm that the mixer cannot start while open, and determine whether closing the lid could cause an unexpected restart. The mechanism should also fail toward a safer state and be testable without major disassembly. Splash control depends on the complete mixing arrangement, not simply the presence of a cover. Blade geometry, operating speed, fill level, viscosity, and chemical addition sequence all influence surface turbulence. Claims of smooth, splash-free flow should be supported by recommended fill ranges, speed data, and observed operation under realistic batch conditions. Safe freeboard must be defined because nominal capacity is not the same as usable mixing volume. Overfill also requires an engineered response. Miscalculation, distraction, foam, poor visibility, or inconsistent transfer can push a batch beyond its safe level. A defined overflow line provides a managed path, but buyers must verify where it discharges, how it connects, whether it suits the actual filling method, and how it will be inspected. For a 400-liter class tank, working volume guidance is as important as the capacity label. Inspection should not require opening the tank. A view glass and temperature gauge can provide process visibility while maintaining containment, particularly when mixing generates heat or requires temperature awareness. Yet these devices can become leak points. Buyers should identify the materials used in every seal, gauge connection, window, drain, port, fitting, coating, and overflow component exposed to caustic liquid or vapor. Corrosion resistance cannot be judged from the tank wall alone. Small components often fail first because they combine chemical exposure with movement, compression, and maintenance handling. Material locations, service limits, replacement intervals, and spare part information should be explicit. Vague claims about chemically resistant parts should remain unverified until supported by a complete contact material list. Documentation and functional testing complete the safety review. The specification sheet, operating manual, product label, and physical equipment should agree on capacity, agitation speed, operating sequence, and component details. Acceptance testing should cover lid interlock behavior, agitation, overflow routing, draining, cleaning, inspection, and maintenance shutdown. Application fit remains essential. A compact pneumatic mixer can reduce field improvisation when air supply is available and the batch size is appropriate. Fixed industrial plants may instead require automated dosing, data logging, exhaust systems, larger process connections, or recipe control. In either setting, the safest selection is the one that combines controlled access, stable flow, managed overflow, compatible contact materials, safe inspection, maintainability, and verifiable operating behavior.